Welcome to Computer Vision Streams channel. I'm your host Anton, and today we will look at tracing capabilities of Gstreamer framework, and we will apply it to measure latency of every plugin inside DeepStream pipeline. So here is a documentation, the link I will share in the description. And the tracing capabilities of Gstreamer have already implemented a couple of tracers using this API described here, and we are interested in the latency tracing capabilities of this API. Let's see a demo. First, we built DeepStream 7.0 container. It's already pre-built, so it used cache. Then we start our container with the possibility to draw windows from our pipeline. After that, because we use a couple of Python, after that we can install a couple of requirements needed for Python script that will parse log generated by Gstreamer tracer, and we can start playing with Gstreamer tracer. So first of all, we will see how to trace pipeline that is launched using GST launch, and that contains a couple of elements. So we just need to define a couple of environment variables and set GST debug to the tracer level. Let's see what kind of messages it will produce. So you see the flag pipeline. That means that we are trying to measure latency of a pipeline end to end. And in the message generated by this tracer, we see a source element, which is the first element of our pipeline, and we also have a sink element, which is the last element of our pipeline. Then we have time and the timestamp of the latency variable. In order to get the latency of every element, we can use flag elements, and you see the message is a little bit different and contains latency measurements for every element separately. We can combine both flags to generate the output file containing both messages for whole pipeline and for every element. In order to use a Python script provided in this example, we need to switch off the coloring of the pipeline. That will be, after that, it will be easier to parse logs, and we need to provide the variable for the name of the output file for the logs. Let's run this command to generate traces log file. After a couple of seconds, we have our traces log file that will contain all the messages from our latency tracer, and I prepared the script that will output different statistics for the whole pipeline and also for separate elements inside the pipeline. The statistics provided are the median latency time, average latency time, minimum maximum latency time, standard deviation, and 99th percentile. We can use the same technique by measuring latency of a custom DeepStream application. For that, I prepared a simple example that we can build inside the repository, that we can build inside the Docker container, and we can run this pipeline with the same environment variable to generate tracing log. It will take a couple of seconds to generate engine from our next file. Let's see what is the pipeline. So in the pipeline, we read some video file, then we mux it and probably resize it. After that, we use a renver to detect different objects, cars, vehicles, and we use this NVIDIA DeepStream plugin to draw bounding boxes and output all bounding boxes in a video on a screen by overlaying the information about frames per second that our pipeline was able to generate. After that, we will use this script. The link you can find below in the description of this video. And we will parse both element latency and pipeline latencies to extract the time and timestamp of every measurement. So here we have our pipeline running, and that reports 30 frames per second. We can stop it. It already generated file that we can process with this script. After this script will parse specific messages of our latency tracer, we can use pandas to create a data frame of different statistics and output to CSV to further processing. So let's see what latencies we have for every element of our pipeline. So our script produces latencies sorted by the median latency of every element. And of course, the first will be the pipeline from beginning to the end. Here we see a small anomaly that our decoding plugins have a bigger latency, which is not translating to the 30 FPS that we have seen on the text overlay on the video. Probably it is because how the tracing functionality is organized and what it is considered to be a finish of a processing. Because I think as a decoder they can generate multiple frames before it considers that the processing is finished. So usually it's better to see the first plugin after the decoder to understand, to better understand the profiling messages. And we see that the bottleneck of our pipeline, not including different latency measurements for decoding, is inference as expected. And inference latency is 63 milliseconds, which will provide us with 30 frames per second as expected. Today we learn how to answer questions that arise in every project. What is the performance of your DeepStream Gstreamer pipeline, and what are the current bottlenecks to apply your optimization efforts? Right now you can answer this question by Gstreamer tracing mechanism and by profiling latency of every element in your pipeline. Write down below what are your favorite instruments of profiling and improving your DeepStream pipelines, and I'll see you in the next video.